On a gloomy May morning, a park ranger crouches at the entrance of Clear Creek, gazing into water that ought to be brimming with trout. With spawning Yellowstone cutthroat trout rushing upstream, this tiny tributary of Yellowstone Lake has become silver-black every spring for as long as records have been kept. She counts the empty riffles 3 times, then radios numbers so low her supervisor asks her to recount. Above the bank, a grizzly track sits pressed fresh into the mud, purposeful and utterly wasted because the bear found nothing waiting in the water. Something that has run like clockwork since before Yellowstone existed as a park, since before the United States existed at all, has quietly stopped, and almost no one outside a small circle of biologists has noticed. When the natural rhythms of our planet begin to disrupt, it impacts everything from wildlife to the future of agriculture. For most of the world, Yellowstone's comeback story was already written, and it was written about wolves. In 1995, gray wolves returned after a 70-year absence, and the cascade of changes to elk behavior, willow growth, and river channels became one of the most celebrated ecological narratives of modern times, retold in classrooms and nature specials worldwide. It's a real, remarkable story, but it isn't the whole story. While cameras followed wolf packs across the Lamar Valley, a second transformation was unfolding beneath the surface of the park's largest lake, one that would ultimately touch more species and reshape more of Yellowstone's food web than the wolves ever did. Almost no one filmed it, because almost no one could see it. It was happening in the dark, cold water, more than 300 feet down. Yellowstone Lake is a geological improbability, a sheet of water covering more than 130 square miles, sitting inside the caldera of one of the largest volcanic systems on Earth, at an elevation over 7,700 feet, where ice can linger into June and water temperatures rarely climb out of the 40s. For thousands of years, since the last Ice Age glaciers carved its basin, the lake and its 40-some tributary streams sustained an unbroken relationship with one native fish, the Yellowstone cutthroat trout, named for the orange-red slashes beneath its jaw. Indigenous peoples, including the Tucutica, or sheep-eater Shoshone, relied on these fish as a seasonal food source, timing their movements to the same spring surges that grizzlies and eagles depended on. When Yellowstone became the world's first national park in 1872, early visitors marveled at streams so full of cutthroat that a person could nearly walk across their backs. That abundance became woven into the park's identity, its fishing lodges, its ranger lore, its whole mythology of untouched wilderness. Fly fishing guides in Gardner, West Yellowstone, and Cody built entire livelihoods around it. Families who had guided anglers for 3 generations spoke of the cutthroat run the way farmers speak of a reliable harvest. Something to set a calendar by, to build a business around. That hard-won reputation would eventually become collateral damage in a crisis nobody saw coming. The first sign of trouble didn't come from a study, it came from an angler. In July 1994, a fisherman working West Thumb pulled up something that didn't belong. A lake trout, a species native to the Great Lakes and other deep northern waters, never before documented in Yellowstone Lake. Biologists were skeptical, then alarmed, then certain. Genetic and habitat analysis suggested the fish had likely been introduced decades earlier, possibly tied to a well-meaning stocking effort at nearby Lewis Lake in the 1890s, where lake trout were planted to diversify sport fishing. Somehow, by accident, illegal release, or slow migration through connected waterways, they crossed into Yellowstone Lake itself, and once there, they found exactly what they needed: cold, deep, structurally complex water with no natural competitor and an enormous, naive food source swimming right above them. Lake trout aren't dramatic predators. They don't chase in open water like a shark. They're patient ambush hunters of deep basins, capable of living 40 years or more and growing past 20 pounds. Unlike cutthroat trout, lake trout don't migrate into shallow streams to spawn. They reproduce over rocky lake bottom shoals in open water, meaning their population could explode almost invisibly, monitored by no one, counted by no spawning survey. A single mature female can produce thousands of eggs a season, and by the time biologists began serious sampling in the late 1990s, the math was already terrifying. Studies would later estimate that one adult lake trout consumes roughly 41 juvenile cutthroat trout per year. With a lake trout population that had likely climbed past several 100,000 by the early 2000s, the annual toll on native cutthroat ran into the tens of millions. Park scientists moved quickly once the first fish was confirmed, but the response revealed how little anyone understood about what they faced. Early netting surveys through the mid-1990s were treated almost as a formality, a check on an oddity, not an emergency. Within 3 years, that assumption collapsed. Test nets in West Thumb and the South Arm began pulling up lake trout of every size class, from fingerlings to fish over 15 pounds. Evidence of a population already breeding successfully across multiple generations. By 1998, Yellowstone Lake's cutthroat population, once estimated at 3 to 4 million spawning adults, had entered a freefall. Within less than a decade, spawning counts in historically prolific tributaries, like Clear Creek, dropped by more than 90%, from tens of thousands of fish to barely a few hundred. The cutthroat weren't simply declining, they were vanishing from entire drainages. And then the rest of the ecosystem began to answer back. Grizzly bears, which had historically converged on Yellowstone Lake's tributary streams each spring to gorge on spawning cutthroat trout, a food source uniquely rich in fat and protein, at a time when bears were emerging hungry from hibernation, began abandoning those streams in the early 2000s. Research led by biologists tracking bear diets found that the percentage of grizzlies observed fishing in spawning streams collapsed from roughly 70% of monitored bears in the 1980s and 1990s to under 10% within about 15 years. Bears did not simply go hungry, they adapted by shifting toward elk calves, army cutworm moths, and whitebark pine seeds, changes that rippled into predator-prey dynamics across the northern range and, some researchers argue, even influenced elk calf survival rates. Bald eagles and ospreys, which had built nesting territories around the lake's shoreline specifically to exploit shallow water spawning trout, saw nesting success decline as an easy seasonal food source vanished. Some pairs abandoned traditional nest sites altogether. River otters, once regular fixtures along cutthroat spawning streams, were documented shifting their diets and ranging farther in search of prey. And in the riparian forests lining those tributaries, scientists began measuring something almost poetic in its subtlety: a decline in the nitrogen isotopes deposited by decomposing fish carcasses and bear scat, meaning the very trees and shrubs along the water's edge were receiving less of the marine-like nutrient pulse that fish runs had delivered for millennia. An ecosystem fueled in part by dead fish was slowly starving in a way no one could see from a hiking trail. The ecological collapse quickly became an economic one. Yellowstone Lake's cutthroat trout fishery had long been considered one of the most productive inland trout fisheries in North America, attracting anglers from around the world whose spending supported outfitters, fishing guides, lodges, restaurants, and local businesses throughout the gateway communities of Wyoming, Montana, and Idaho. The fishery formed an important part of a broader Yellowstone tourism economy that today generates well over $500 million annually across the surrounding region. As cutthroat trout numbers plummeted through the late 1990s and early 2000s, the effects spread far beyond the lake itself. Catch rates for native trout in some areas fell by more than 90%, and the legendary spring runs that had drawn generations of anglers became increasingly unreliable. Outfitters who had built their reputations around Yellowstone Lake's tributaries watched bookings decline as word spread that the famous fishery was no longer what it had once been. Some guiding businesses shifted their operations to other rivers within the park in an effort to survive, while others closed altogether. Regional tourism economists later estimated that the decline of the Yellowstone Lake cutthroat fishery contributed to fisheries-related economic losses reaching into the tens of millions of dollars over the following 2 decades. For many local families, the consequences were deeply personal. Businesses that had guided anglers across 3 generations lost dependable seasonal income. Returning clients canceled long-planned fishing trips or chose other destinations altogether. What appeared in scientific reports as declining fish populations translated, in everyday life, into fewer visitors, fewer bookings, lost jobs, and shrinking revenue for communities whose livelihoods had long depended on the annual return of Yellowstone's native trout. At the same time, the financial burden extended beyond lost tourism. Protecting what remained of the native fish population would ultimately require an unprecedented conservation effort, transforming a naturally self-sustaining fishery into one of the most expensive invasive species management challenges ever faced by the National Park Service. Protecting the lake's native fish required intervention on a scale never before attempted inside a national park. Managers launched an aggressive gill netting program to remove lake trout before they could consume another generation of cutthroat. Over the following decades, the effort grew into one of the most expensive invasive fish suppression programs in North America, funded through federal appropriations and nonprofit partnerships. The campaign has cost tens of millions of dollars and removed more than 3 million lake trout. The financial commitment remains enormous, roughly $2 million a year just to keep numbers suppressed. It's a striking contrast to the ecosystem that existed before the invasion, when healthy cutthroat populations moved vast amounts of nutrient energy from lake to forest every spring simply by following their natural migration. Today, millions are spent annually trying to restore a system that once sustained itself entirely on its own. Scientists soon realized simple removal wouldn't be enough. The recovery effort evolved from a straightforward campaign into an adaptive program that continuously tested new strategies to stay ahead of the invasive population. What began in the late 1990s as a modest operation, with a handful of Park Service boats expanded by the mid-2010s into a commercial-scale effort, with contracted vessels using advanced sonar to locate lake trout concentrations each season. Researchers also experimented with unconventional techniques, like sinking captured lake trout carcasses onto known spawning shoals, where decomposition lowered oxygen levels around developing eggs, suppressing future generations before they could hatch. After nearly 3 decades, Yellowstone's effort had become one of the largest, longest-running invasive fish suppression campaigns in North America. Fisheries managers elsewhere, including at Lake Tahoe and Glacier National Park, began looking to Yellowstone as a model, turning the park's hard-earned experience into a blueprint for conservation far beyond its own borders. This could have been just another cautionary tale about an invasive species. But deeper investigation, led over 2 decades by Dr. Todd Cole and the National Park Service's Native Fish Conservation Program, uncovered something more interesting than a simple villain and victim. Cole's team pieced together, survey by survey, sample by sample, that the Yellowstone cutthroat trout had never simply been prey. It had been infrastructure. Each spring, as millions of cutthroat pushed from the lake into shallow streams to spawn, they functioned as a biological conveyor belt, hauling nutrients accumulated in the open lake for years and depositing that energy into mountain streams and surrounding forests. Bears, eagles, otters, ravens, gulls, and countless invertebrates weren't simply eating fish, they were redistributing lake-grown energy across a terrestrial landscape that couldn't otherwise reach it. Lake trout, by contrast, stayed in deep water their whole lives and died there, locking that energy permanently at the bottom of the lake, unreachable by any bear, eagle, or root system. The invasion hadn't just removed a species, it had severed a pathway connecting an aquatic ecosystem to a terrestrial one, operating since the glaciers retreated some 14,000 years ago. The scale of the story kept widening. What began as one tributary with fewer fish became a lake-wide population collapse. What began as a fisheries problem became a grisly behavioral shift documented across the park's entire northern range. What began as a local anomaly became a case study cited internationally, in the growing field of cross-ecosystem nutrient transfer, alongside research on Pacific salmon runs in Alaska and British Columbia, where spawning fish have been shown to fertilize forests a mile or more from a riverbank. Yellowstone, it turned out, wasn't an isolated curiosity. It was a high-profile domestic example of a pattern documented worldwide, that the health of forests, birds, and mammals, far from any lake or river, can depend on the uninterrupted movement of a single migratory fish. There was a twist still to come, one that reframed everything. For years, the recovery strategy focused almost entirely on removing lake trout, treating the crisis as a straightforward predator elimination problem. But as gill netting intensified through the 2010s, researchers noticed something unexpected in the data. Cutthroat trout were not just failing to recover in a simple linear fashion tied to lake trout numbers. Certain populations were showing surprising resilience in specific tributaries, with intact spawning habitat and cold groundwater inputs, even while lake-wide numbers remained low. It became clear that habitat quality in the spawning streams themselves, some degraded over decades by sedimentation, stream bank erosion, and shifting hydrology, possibly linked to a warming regional climate, was quietly determining which fish populations could bounce back once predation pressure eased, and which could not. The lake trout had been the dramatic, visible threat, the one with a face and a hook, and a boat full of biologists hunting it. But the quieter threat, the one working in parallel the entire time, was the slow degradation of the very streams the cutthroat needed to complete the migration that made them so important in the first place. Removing the predator alone would not be enough. The rivers themselves needed attention too. Over millions of years, cutthroat trout across western North America diverged into a mosaic of subspecies, each shaped by isolation in a particular watershed. A reminder that the Yellowstone cutthroat trout at the center of this story is the product of an extraordinarily long negotiation with this landscape, one that a single 1890s stalking decision nearly undid in less than a human lifetime. That asymmetry, thousands of years of adaptation against a few decades of disruption, is why biologists call the lake trout invasion one of the costliest, most consequential fisheries crises in the park's history, and why recovery has been treated less as routine management than as an attempt to preserve something closer to deep time itself. By the early 2020s, more than 25 years into the campaign, the numbers began to bend the right way. Lake trout catch per unit effort started declining in key areas for the first time since monitoring began, suggesting removal was finally outpacing reproduction. Spawning counts in tributaries, like Clear Creek, showed modest but real increases, some more than doubling from their lowest years, though still far below historic highs. Grizzly use of spawning streams ticked up slightly, where cutthroat were rebounding, and ospreys and eagles began returning to shoreline territories gone quiet for years. None of it added up to full recovery. Every biologist says so. But for the first time in a generation, the conveyor belt was showing faint signs of moving again. What makes this story different from Yellowstone's famous wolf narrative isn't that it lacks drama, it's that the drama is distributed, patient, and largely invisible to a casual visitor at a scenic overlook. There's no camera-ready predator loping across a meadow at dawn. There's a fish most tourists never see, moving through water they never look into, feeding animals they never connect to that water at all. Yet the total ecological footprint of this quiet crisis rivals or exceeds anything attributed to the wolves. It reveals something uncomfortable about how we perceive ecosystems. We notice predators, we build documentaries around teeth and claws and dramatic kills, and we're far slower to notice the unglamorous species moving nutrients and stitching one habitat to another. If you have made it this far into this story, you are exactly the kind of viewer this channel is built for. Someone willing to look past the obvious headline and follow a mystery all the way down to the water. Whether cutthroat trout will ever again fill Clear Creek the way they did in early 20th century photographs remains genuinely uncertain. Climate projections suggest warmer, more variable stream conditions ahead, a factor that could work against recovery just as fast as gill netting works for it. What is certain is that the ranger standing at that empty creek years ago was witnessing more than a fish shortage. She was witnessing the interruption of a 14,000-year-old conversation between a lake and its forests, carried one silverfish at a time. Somewhere beneath the surface of Yellowstone Lake tonight, that conversation is still being fought over, net by net, season by season, in water too cold and dark for any camera to follow. And in a tributary not far away, a bear may already be waiting, the way bears have waited every spring since the ice retreated, for a message written in fish that hasn't fully arrived yet, but might, finally, be on its way.